Oh, I realized I was recording the whole. I usually pause the recording every time I restart I have to restart Zoom each time, and then pause the recording at the very beginning because it starts recording automatically. So if anybody is watching this, you got about 5 minutes of dinging and anyway, just random stuff. I guess I could go into YouTube and trim it down. So we do have a few people that have watched the videos. They don't get a lot. I do it mainly because we also have 2 students who are in the machining program. They're not actually in the CTS program, but they're taking this class, but they have an overlap with their actual hands-on machining class sometimes. So I record these just in case, or if somebody wants to watch them. Usually not super exciting, but all right, today we're going to be talking about RAM, memory, RAM, that kind of stuff. And then also looking at one of our longer term assignments for these 2 classes. As I mentioned, got to stand up once in a while, my legs. That's one thing I miss about the actual classroom is that, walking around the classroom, and I had a stand-up desk where I could stand up and, stand at the desk, which is nice, but not used to sitting down so much. Getting old. All right, so RAM, also known as system memory. Now, if you guys are doing IT, like tech support kind of stuff, or working with people, one thing that kind of comes up is that there's some real confusion about RAM and memory versus, I'll put it over here, hard drive space, right? Because they're measured in the same terminology, right? Like if you guys are talking to somebody, how many of you have ever worked with somebody or talked to somebody and they just generally said, my computer is out of memory, right? If you had people tell you, I don't count how many times I've had people tell me, hey, my computer is out of memory. And automatically, right, I'm thinking RAM. Now, it could be that that's the case. I mean, you might get an error message on the computer saying something that it's running low on RAM or system memory or something to that effect. But when somebody says they're out of memory, what else could they be talking about?
Their hard drive.
Yeah, I mean, who was it on here that only had like 4 gigs of space left? One of the Brandons, I think. No, wasn't Brandon Harrington. It was maybe the other Brandon. Anyway.
I said I had like 40.
Oh, it was maybe there was somebody that had like just a little bit left, like 4 gigs left. Anyway, doesn't matter. But yeah, because they're measured in, gigabytes with a big B, gigabytes, you might have, 8 gigabytes of RAM or 4 gigabytes of RAM or whatever. So RAM and system memory are related, but when somebody says that they're out of memory, a lot of times you ask them more questions. This kind of goes back to our chapter that was on, how to be a nice tech support person or whatever. Like, here's what not to say, or here's what, so ask them some leading questions and say, well, what did the error message say exactly? That kind of thing. Because, if the hard drive is getting full, now these are related in a sense, because, if you have 8 gigabytes of RAM, like I just showed you on my computer last hour, that, my system, I had tons of stuff open, and I was running VirtualBox at the same time, which of course runs an entire other operating system in memory. So I was using a ton of memory. But if somebody is, excuse me, if you're physically out of hard drive space, then what it will start to do is cache memory on the hard drive. So HDD is hard disk drive as opposed to a solid state disk. So this could be called virtual memory. So virtual memory is on the hard drive. It's a cached area on the hard drive. You need to have enough extra space. This is also known as a swap file. So swap file, virtual memory, same idea. So you've got some space on the hard drive where if you run out of RAM, because remember, anything that's running in memory in RAM is your operating system. Basically any software. I mean, the computers don't do anything without software. So, and then the way it, you've got your processor, which is processing data all the time. Your hard drive is where you've got well, they refer to it as permanent storage, but as you know, hard drives can fail. But for our discussion, hard drives are permanent or semi-permanent storage where the operating system is located and any software, that sort of thing. So anything you want to load goes off the hard drive first into your RAM and then is managed and processed by the CPU. But as you start filling up your available memory, if it gets to the point where it's maxed out, then it's going to use part of your hard drive as pretend RAM, pretend memory, which is one of the things we'll talk, why we're talking about is that a RAM upgrade is a good, good upgrade for a lot of systems. In terms of bang for your buck for system upgrades, the CPU is discussed as well. Replacing or possibly upgrading a CPU in the book is a discussion. But that's a little bit more of a major investment. And in terms of, and it's definitely doable. So you could look at your system and say, okay, maybe, what processor does my system support and could I upgrade the processor? But as you guys know, as you start changing processors, then maybe you're going to have to change the motherboard and everything else. Whereas a RAM upgrade can be, simply adding more RAM to a system if you have available slots to put the memory into. But if you're running into and hitting a swap file, that's really going to affect your system performance. Even if this is on a solid state disk or an SSD, solid state drive, solid state drives are legitimately faster, obviously, than a mechanical hard drive. They'll refer to these as rotational drives as well. So a rotational drive, they've been around forever. They still have a place, obviously, in terms of just large quantities of data storage. I was looking at buying an external drive, and Costco had these little 1 terabyte NVMe drives on sale, or will have them on sale. I'm like, oh, I don't buy computer stuff very often, but external drives that are fast are pretty handy. But for the same price, you could get an 8 terabyte mechanical drive, in an enclosure. So I'm just talking about external drives, but a huge difference in size of capacity for storage space between your traditional mechanical or rotating hard drives and solid state drives. And solid state drives are definitely faster, but they're still not as fast as your main system memory, your actual RAM on the computer. And RAM on the computer has, as computers have gotten faster, it's sort of a leapfrog kind of thing. So as new CPUs are developed that are running at faster internal frequencies, then RAM also had to be developed that would be able to communicate with the CPU. Because, as we're talking about, you've got your CPU, and back from one of the earlier chapters, you had your North Bridge chipset, which would connect to your RAM, and then you had your South Bridge chipset, which would connect to things like USB, the slower stuff, your hard drive connection, stuff like that. But the fast connections to the North Bridge, your RAM and your video. Now the North Bridge and South Bridge has kind of become integrated into CPU design as well, but it's still a good way of explaining how this stuff is working. So the RAM needs a fast connection to your system board. So as the CPU might be operating at the front side bus speed might be, let's say, 200 megahertz. The RAM is going to have to be operating at that speed or faster to be able to keep up with the information that's going through this bus back and forth between the CPU. So stuff comes off the hard drive first, it gets loaded into the memory, and then your CPU is going to be accessing chunks of data that are in system memory, that are in RAM. So as you start adding, more and more programs, so the amount of RAM that you have on the system is going to ultimately limit how many things you can run simultaneously. How many programs can you have on? So like my computer is a good example. I don't know how many tabs I have open. I can hardly even count them across the top of the screen. And I've got VirtualBox still running in the background, which I should probably shut off now that I think about it. Just shut those down. So if you have 8 gigabytes of RAM, you're not going to be able to multitask as well and run lots of stuff. Now, there's kind of a sweet spot in terms of how much RAM. So as you're talking about like the speed of the RAM, as the CPUs get faster and faster, maybe they start running at a 400 megahertz bus speed, and then you need RAM that needs to be able to keep up with that. they then started having what's called DDR RAM, which is double data rate RAM, which would run at a multiple of the clock speed. So the way that the RAM, so you'd have like DDR 400 RAM, maybe, like, you know, that would have its speed that it's running. So these numbers that are associated with the RAM is what we're going to be talking about a little bit, because it's good to kind of understand what they mean. Ultimately, though, when you are looking this stuff up, what you'll have are specs that you'd Google, right? And you just say, okay, I need some, you know, DDR4, whatever you have, or DDR2. So then they came up with generations of it. So you got DDR, DDR2, DDR3, 4, 5, I believe is more like on video cards just at the moment. But, you know, the RAM, the big thing to remember is that, you know, RAM just keeps, as these things, CPUs get faster and have multiple cores, the bus speed that it's running at, the communication that is happening. So if this is the bus that's actually, you know, part of the motherboard, as this data transfer rate gets faster and faster, it has to have the ability to be able to get that information back and forth to the RAM. And then the RAM has to keep up as well. So it isn't just like one thing progresses, as, you know, talking about Moore's law. Moore's law specifically applies to the CPU and the number of transistors that are in it and stuff like that. But, you know, as each thing progresses, you need to have faster chipsets. The motherboards need to be able to keep up with the bus speed. The RAM needs to be able to keep up. So it's definitely a, you know, this incremental thing where all of them need to be playing together to have a fast computer. And of course, the video subsystem as well. I mean, video cards are basically another computer on a card. So you've got your graphics processor. It has its own system, own RAM as part of the graphics card. Here I'm pointing to a blank screen, right? So, so the RAM speed, we'll talk about that. So this comes up, like I said, last hour, I told you guys somebody gave me an old Mac laptop, and I was like, oh, that's cool. You know, I have an old Mac at home, you know, an old iMac that I refurbished, but the laptops are kind of cool. And I like playing around with the operating system. I mean, I'm primarily a Windows user. I've got a Linux box at home as well. But the Mac OS is legitimately a pretty cool operating system. I mean, a lot of people like, oh, you know, the Macs or whatever, especially people that are gamers. I mean, for a long time, the Windows world has pretty much dominated gaming, and, you know, that's a huge industry within the, you know, within our, you know, the hardware environment. But Macs, I think, have a kind of a neat operating system, the way they function. However, this thing only had 4 gigs of RAM. And so and when I got it, it was super, super, super slow. So they had a whole bunch of weird, you know, like software that was trying to load. So I Googled it, of course, and there's different ways of resetting the Mac. And one way, which was kind of cool, is, you know, you hook it up to the internet and then you reboot it, and there's a special function key. When you reboot it, you can do an over-the-air reinstallation. So it's connecting to the internet, it's downloading a new image of the operating system, and it does a complete reinstall. It wipes it and reinstalls it. So that was pretty cool. But I quickly discovered that this particular Mac had really, you know, not very much RAM, only 4 gigs. But it was also maxed out. Like, it couldn't go, it could run High Sierra. Who's our Mac users in here? Any Mac users? I thought that we had one in the other class. So anyway, High Sierra, Apple has funny names for their operating systems, but this operating system is from a few years ago, and it won't run any of the newer operating systems, which is somewhat limiting. So if you go to download an application, it says, oh, sorry, you need Mac OS 10.14 and you have Mac OS 10.12 or 10.13. So it has a numeric indicator and then also names for their operating systems. But yeah, you guys might run into supporting Apple computers as well, Macs. So if you can gain any experience with them or dink around with one at some point, definitely worth it. I know one of the students was working for Wenatchee School District, and they use a lot of Macs there as well. So get some support with that. All right, so we're going to look at, oh, so that was why I brought up in the discussion. So I looked up, okay, Macs, if you're ever working with them, have a little tiny number on the back of them with a revision date, and they kind of go by the year that they were made. So this one happens to be a MacBook Pro. It's a late 2011 model. They had an earlier model, and then it also has a number. So it's like an A1708, I think was the model number. And so you can Google it, look it up, find out what kind of RAM you have in there, and then order appropriately, right? The other thing you want to, oh, Ryan, question, good. Yes.
So with the Macs, aren't most of their models like all-in-ones or laptops?
Yeah, this one is a laptop. Luckily, this is the older laptop that actually has screws that you can take apart. The newer Mac laptop, so the guy that gave it to me has a newer Mac laptop, and this was an old one. The newer ones have gotten thinner and are very sleek in their design, but they're also glued together. So if you want to take them apart, they're not very user serviceable. This one, the one I got now, it does happen to have, so it's called their unibody replacement. I'll share the picture of it real quick if you're curious. So, all right, so here's a shot of the inside of the case, and you can see the RAM module there in the guy's fingers. Now, laptop memory is almost always what they call an SODIMM, a small outline. And this particular laptop has two of them in there. It runs DDR3 RAM. And so again, the DDR stands for double data rate. And then there's different generations of the RAM, DDR2, DDR3, DDR4. And then it also has a speed rating. Now there's two different ways that the speed rating is used. The DDR, it might say DDR 400, or it might say PC 3200, something like that. So there is a PC rating, and then there's a megahertz rating for the RAM. But yeah, here's the back of the, so you take off all these little screws on these older Macs, and the bottom, this is a pretty nice website. It just kind of shows you pry off the back of the laptop. Then you disconnect the battery so that while you're working with it, you don't have electricity. So another good heads up on many of the, PC, or what we would think of Intel based, which is odd. The Macs use Intel processors as well. And they can run Windows in parallels. Anyway, you're disconnecting the battery here. On many of the laptops you'd be working with, the battery is easily accessible, and you just remove the battery out of the bottom of the laptop prior to working on it. So I was curious, it has 4 gigs of RAM. So I was trying to figure out, in terms of upgrading the memory, if it had an empty slot, right? So if you have an empty slot, you can add RAM, but you don't end up with any leftover parts, right? So it's always a good idea to try to figure out, what is the configuration, and you can look it up, or there's a scanning tool that you can use from Crucial Memory, which we'll look at in a second. But I was trying to figure out, okay, if it's only got 4 gigs of RAM, is that two gigabyte modules, or does it have 4 gigs and an empty slot? Well, as it turns out, it came with two gigabyte modules, and they're stacked on top of each other. So they're relatively easy to get out once you take the back off of the computer. And you can see that one there. But they're both, so if I'm going to upgrade the RAM, I'm going to have to take out both of the old modules. I'll have a leftover parts, right? They're not going to be, and they're really not worth anything. So there's not much you can do with a 2 gigabyte RAM module. Most people don't want those because they're upgrading their computer, and those aren't very functional in terms of any kind of upgrade. They might be good for replacement parts if you really needed them. But all right, so the short or small outline RAM modules are, if you can still see my screen, a full length RAM module is about 5 inches long, and the SODIMMs are about 3. They're not half size, but they're close to it. And they do contain the same amount of RAM. As you've got the actual RAM chips, or the black chips that are on there. The module itself just has edge connectors. Here it's showing the 2 little plastic clips that clip it in. So you just kind of spread those out. The RAM module should then pop up at an angle. These are different than the RAM modules in a desktop computer that go straight down into a slot. These are always on their side. You kind of clip in the edge of the module and then lay it down flat until it snaps into place. So here you can see these. So my intention is I'm going to take this Mac apart. I'll do it on, I'll maybe either record a video or just we'll play with it in class. I'll get it mostly taken apart so we can see the inside of it. The other thing that was goofy is that the keyboard is kind of sticky. So you can replace the keyboard, but you have to basically take the entire computer apart from the inside. So you take the motherboard out and everything else, and then you put a new keyboard in. And stack everything in place. But a RAM module is a pretty easy upgrade for many computers. Let's see here, I'll stop the share for a second. But the first thing to determine is, how fast is, what is the RAM that it needs? So it needed DDR, and it was 1333. That. Okay. So the RAM that I needed was DDR 1333, and that's the speed in megahertz. Now that has a PC rating of PC 10,600. So it's the same stuff. And a lot of you guys probably know this if you've either built your own computer or done upgrades, but we're just kind of walking through it again. Those two, the PC rating is supposed to indicate the speed of the band, including the bandwidth, right? So double data rate indicates that it can process data on the uphill and downhill of the clock frequency. So RAM, like a lot of things in the computer, has like a clock frequency that it's operating at. And frequencies indicate that you've got a wave pattern, right? And so the DDR RAM processes data kind of on the uphill part of the wave and the downhill, if you want to think of it that way. It's a weird way to think about it. But then they decided, okay, well, we've got this clock frequency that it's having to do, but now we've got RAM that's also processing data, double data rate. So we need to come up with a way to indicate bandwidth as well. So they said, okay, well, if you've got 8 bits of bandwidth, so essentially the clock frequency, if you multiply it by 8, gives you the PC rating. So the PC rating was a way to kind of have a flat description of, okay, here's the RAM, it's running at a clock frequency, and then here's your bandwidth. If you're combining those two, it's kind of a generic way, which ends up confusing people because you have, you've got 2 different numbers describing the same thing. So here, this is a pretty decent article. I'll post this in the chat. If anybody that's kind of curious about this, if you are kind of familiar with RAM already, then this may not be news to you, or again, you can build a computer and run a computer and upgrade RAM without even knowing what the numbers mean, as long as you get the right RAM into the slot, right? So if you are researching your computer and you figure out it has this type of RAM already, you can run Speccy or system information or any of those things, and it'll tell you what kind of RAM you have. The big thing is, do you have spots to put it? Do you have upgrade slots to put it into? Many full-size desktop computers have 4 slots for RAM. And if you're building a computer, it's nice to just put 2 sticks of memory in it to start with, and then leave 2 open. So for instance, if you wanted 16 gigabytes of RAM, you'd buy 2 8-gigabyte sticks, populate the slots, and then it would give you an upgrade path for the future. You could also put in 4 4-gigabyte sticks, maybe if they were cheaper or something like that. So, it's kind of one of those things of determining the upgrade path. If you have a little tiny computer, I brought it in, it's still out in the truck, my little shoebox style computer, it only had 2 slots of RAM to begin with because it was one of those micro ATX boards. So very compact, did not have extra slots for anything. Okay, so this article talks about different RAM speeds, starting with the original double data rate. Before you had double data rate, you had just SIMs, regular single inline memory modules. You're not going to see those unless you're actually working on an antique computer for some reason. So, but they started out, it has to match up to the clock frequency. This is talking about the front side bus that I was just talking about, the actual bus speed that's linked to the CPU. Okay, so the original ones might have been called DDR 200 or DDR 266. Because it's double the bus speed. So you've got either 100 megahertz bus, or if you had 133 megahertz, you'd have DDR 266. So moving on to the newer stuff, it says, this is an obvious system, it says, but RAM transfers aren't very convenient units to work in. It's much more common to talk about data in terms of bytes. So it says to make the DIMM speeds more understandable, they're also giving a PC rating, which expresses their bandwidth in megabytes per second. So, but when you go to buy RAM, it could have one of these numbers or the other or both. So you got to kind of know what you're looking for. It says PC ratings can be calculated very simply. Each RAM transfer consists of a 64-bit word or 8 bytes, right? So to convert data transfers into bytes per second, you multiply by 8. So DDR 200 is the same thing as PC 1600. Now, when you get into DDR2 or DDR3, it will be an equivalent rating in PC2 or PC3 for the numbers, right? So make sure you're buying the right stuff and you're good to go. Okay, so it's talking about, you know, basically the faster RAM has higher frequency that it can handle. And, you know, again, if you're thinking about frequency rating, so let's see if we got, that's pretty much it for that stuff.
Do you know if the CAS latency, when it talks about what is CAS again, like the strobe, like the amount of time, like the columns or something like that?
Yeah.
That I've been recently trying to wrap my head around a little bit more, because like CAS latency 16 or 18, the lower the better. But given the PC rating and the megahertz and all that, I'm just kind of curious.
So CAS. So on a traditional hard drive, and again, I'm dumbing down the pictures, not just for my benefit, but so on a traditional hard drive, you've got data that's laid out in sectors and tracks. And so you've got basically, you can't see these things, but you've got tracks, like circular tracks, and then pie-shaped sectors. So the data can be spread out, if you guys can see the board, the data can be spread out into these different chunks on the hard drive. And it's a way of organizing the drive to be able to find stuff, kind of like your old Battleship game where it's like B8 or whatever. So you've got data that's organized in the drive. And since this is spinning, you know, the drive has these read-write heads that come out here and they swing back and forth. And so as the drive is spinning around, it's got one revolution per chance to pick up data off of these columns, or not columns, but sectors and tracks. RAM is solid state. So same thing with SSD, solid state RAM. And I'm drawing this out kind of like a chart here, but data in RAM, and remember RAM needs to be refreshed constantly. So if you lose power, what happens to the data that's on your RAM module? Right, it's gone. Hard drives and solid state hard drives, when you lose power, obviously stuff stays there. It's not the same technology. RAM needs to be constantly refreshed. And since it's, you know, drawing this out, again, it doesn't look like this, but if you've actually got chips on here. But if you think of RAM having information, you've got columns that are going down here. So each column is like a storage cabinet, would be a way to think of it. You know, each column would be a storage cabinet with data in it. And that data is being refreshed at this really high frequency rate. So the amount of time that it takes to get data out of this column before it's refreshed to the next time period is your latency time. And lower is faster. So again, from a perspective of somebody building a computer or doing, you know, basic IT stuff, we're not going to be building RAM. But it's kind of nice to know generally how it works. CAS latency, usually when you're shopping for RAM, they're all going to be almost identical. It's, in fact, more recently, as I've been shopping for RAM, I haven't seen, well, for the most part, all the RAM modules that I was looking at had the same CAS latency. So it wasn't like I had to choose one or the other and stuff like that. If you do have a choice, pick the one with lower latency. Also, when you're buying RAM, if you're buying RAM in pairs, which a lot of times you'll need to do with the way the motherboards are set up, you'll need to be installing the RAM in pairs typically. So buy RAM or groups of 4. When I buy RAM, I try to buy it at the same time if I can, and then if I'm upgrading, I'll try to get specs, obviously, that match up with the original RAM. If I can, I'll buy the exact same, you know, if my computer has 2 4-gig sticks and it's got 8 gigs of RAM, when I want to upgrade to 16, I'm going to look for RAM that's identical to the other pair of RAM. You know, it's going to have the same specs, same CAS latency, all that good stuff. And if you do buy RAM, like, so for instance, the Mac that I was looking at, it needed DDR 1333, which is the frequency rating. I could buy, it was DDR3, excuse me, it's DDR3 RAM. I could buy RAM that's faster than what it needs, but I don't want to buy RAM that's slower in its frequency rate. If you guys are building like a gaming computer, for instance, and you're intending to maybe even overclock it a little bit, then you want to buy RAM that gives you some headroom, so that if you wanted to overclock it, that RAM is rated for the faster speed rating. It isn't necessarily that you might use it, but it would give you that headroom if you wanted to overclock it. Because remember, when you overclock the CPU, that also is overclocking the speed that it's talking to the RAM. So you'll need to have RAM that can keep up with that, that speed rating. So, all right. Something else I was going to show you guys. So I got close out some of my many windows. All right.
I have a quick question.
Absolutely. Who's that, Ryan?
Yeah, so
go ahead.
on my laptop, are laptops sometimes, do they come overclocked when you buy them, or do you have to do that yourself?
Typically, laptops are not overclocked, and many laptops do not have the capability to be overclocked. Remember, that's dependent on the BIOS or UEFI. I'm going to, again, I apologize. I will continue, like many people, calling it the system BIOS, even though it's technically a UEFI. Anyway, if you go into the UEFI or into the setup, into your BIOS settings, most of that will be grayed out. On the gaming computer that we have in the back, you know, if you go into your UEFI and it's got options to change clock speed or change bus speed, then you can overclock your CPU. Most like Dells and things you buy off the shelf, like factory built desktop computers, and almost every laptop I've ever looked at does not have the capability to overclock, right? So like our Dell computers, like the one that I'm sitting at right here, I can't show you in Zoom because obviously I'd have to reboot, but I can get the camera out on Monday, but we'll be looking at that. Yeah, if you go into your own BIOS on your laptop or on a desktop, you know, you'll see that there might be settings there for the CPU type and clock speed and stuff, but they're going to be grayed out. You won't be able to change them. So
Yeah, I was just wondering that, because when I looked at my task manager on my laptop and I clicked on my CPU, it was like, it said it could go 1.0 millibits, or if I can remember correctly, millibits or something.
Okay.
But it was like running at 2.0 or like 1.6. It like jumped everywhere.
Yeah, and the way CPUs work, some of them do have like this hyper threading, like if it's an Intel, and then they also have some sort of like little turbo cache thing. The way CPUs work internally is pretty, like, it's almost like magic, but the base clock speed is probably fixed, you know, the speed that it's set at as a recognized actual CPU. So you're talking about going into Task Manager and looking at your performance tab maybe, or
yeah.
So CPU here. Yeah, I'll share mine real quick so we can take a look at it. All right. So here's the CPU, and it's got utilization, processes, and then the base speed it says is 4.2 gigahertz. And I'm not sure what, again, I'm not with Ryan's, I'm not sure how his was set up or what it was showing here, but you can also see the level 1 cache and stuff that's level 2 cache. So cache RAM on the CPU as well is kind of like, we were just talking about swap files with hard drives. The CPUs have a little tiny bits of RAM right on the die as well, and those act like storage areas. So in the book, when it's talking about level 1 or on die cache, those are, if you think about it, kind of like irrigation ponds or something. Or you've got a series of irrigation ponds, and you're draining water out of them. The CPU is going to have a little tiny storage area for data that's very close by, and it's going to keep filling up that cache out of your main system memory too. So anything that's a cache anywhere in the system, hard drives will have caches as well. So all those are set up to be kind of like buffers for information. So the whole idea is you don't want the CPU to run dry. You don't want it to run out of information. It needs to be constantly fed data for an efficient system. So they're setting up these caches in order. So you got level 1, level 2, level 3. You've got your main system memory as kind of a cache as well. It's not called that, but that's, it's filling up with data to be sent out to the computer. And the question that I think it was Kyle was talking about is, with CAS latency and RAS, so you've got columns and rows of data. And, again, in my head, I'm not sure how many of you ever played Battleship, but you had these little like columns and rows of like C9 or D8 or whatever. It has to find that information from somewhere. And the lag time, how long it takes to get information out of the RAM is part of that latency. But I was just going to look on Newegg and see, look in the specs. Sometimes you have to dig into the specs a little bit to see. So there's CAS latency of 9. So I'm looking up, actually I should look up SODIMMs here, but DDR3. I'm already in the, oh yeah, I'm looking at desktop memory, so I need to look at laptop memory. All right, yeah, so, getting sidetracked already. Anyway, yeah, anytime you get, just throw out questions anytime you want here. And all right, so I'll share my screen again. So just kind of looking at RAM. So, after I figured out that the RAM that
that's cheap.
yeah, so one thing about computers too is that some of the older stuff is cheaper, and then at a certain point when it becomes rare, like when they quit making DDR3, finding RAM for an old computer can sometimes get more expensive than you might think. It's like, oh man, do I want to really replace that RAM or upgrade it or whatever? So yeah, what I did is I ordered 2 4-gigabyte modules. I didn't order from Newegg, but I just popped up their screen. And so, it's trying to look under the specs here. Okay, so the CAS latency for this one is 13. Probably if I looked at them, and then so also mine needed the 1333. So it was this one here. I didn't order RAM that was any faster. If you were building a computer, or your CPU is going to dictate what RAM is required. So your CPU might be an Intel i7 blah blah blah. It needs a certain socket type. It fits into a certain motherboard, and then it's going to specify it needs a certain type of RAM. If you spec it out, so this is DDR 1333. I could have bought, well, it gets into PC3L. I probably could have put in RAM that was a little bit faster if I wanted to, but it's not going to give me any benefit because I'm not overclocking the laptop. I want it, and the Macs are sometimes kind of picky about what type of RAM they want. So I ordered 2 4-gigabyte modules. It originally had 2 2-gigabyte modules in it. For the RAM. So if I look at this and I'm looking at just just DDR3 1333, and I'm kind of comparing them, I'm guessing that the CAS latency is about the same on all of them. So I wasn't really too concerned about it. Oh no, this has got, there's 9 and 11. There you go. All right. So if I did have a choice, there we go. So if I did have a choice there, I'd pick the CAS latency of 9. If all of the things are being equal, get the one with lower latency. I mean, it makes sense.
That just kind of comes down to the quote unquote silicon lottery. Is it just what material is like capable of? It's like how.
Yeah. So when they're making these things, some people speculate that, they're testing these RAM chips, right? And so they'll say, okay, here, all of these will meet this spec. They get a CAS latency of 9. These will meet the minimum spec of 11. So there may be higher quality. I was actually surprised to see this. You've got 2 different choices there, but actually that's bumping it up to DDR3 1600 is. So sometimes it's weird. The faster the RAM that's faster sometimes will have a worse CAS latency. So it's so here you've got
that, because a lot of the DDR4 when I was in the market is anywhere from like 16 to 18.
Yeah, so it has to do with the way they're designing the RAM, and the way I picture it. Here's the way I think about weird stuff is if I have way more file cabinets, it's going to take me longer to find my files, right? Versus if I have fewer file cabinets, my latency is going to be quicker because I don't have to look through as many papers in my file cabinets. That's kind of how I visualize it in terms of the RAM and the CAS latency stuff. But like I said, as long as your RAM meets the minimum requirements, you should be okay. If you do have a choice and you make sure all the other specs are the same, then get the one with the lowest CAS latency, but get them all matching, right? Because it's always the weakest link in the chain. If you've got some that are, you know, DDR 1600 and some that are DDR3 1333, your system's going to be running it at 1333, even though you have maybe one or, you know, maybe you've got 2 sticks of 1600 and 2 sticks of 1333, doesn't make a difference. You're running at 1333. You know, you're not going to be able to overclock. So RAM, you know, buy it so that it matches. Here you can see that this is also non-error checking, non-ECC. So when you're talking about RAM, have any of you ever run into ECC RAM or had a reason to purchase it or know what I've had this come up before? Okay, so for most home computers and gaming systems and all that stuff, your RAM is going to be non-ECC RAM. You will see this typically on servers where it's error checking and correcting is what it stands for, I believe. Don't quote me on that. So basically, it has an extra chip on the RAM and it double checks the math on it. So if there is an error, some RAM can do error checking but not correcting, and some can actually correct what single bit errors when it's transferring data. Most home computers do not have a requirement for ECC RAM. If you're putting RAM into a server, I've got one sitting there. Servers typically require, you know, buffered RAM or ECC RAM. So you really want to be extra careful if you're upgrading or an actual server, like one that was built as a server, and make sure you get RAM that is supported, that it all matches, and that you're supporting what the server is requiring for that. And it's just a matter of, you know, picking the right stuff. So this is desktop memory. They probably have a category for server memory as well if I'm in here. So components, memory, laptop. Yeah, so in my categories here, not that you guys care too much, but in my categories, you got desktop, laptop, Mac memory, again, because sometimes they're very specific about what kind of memory they want. Server, and I ended up ordering mine, you know, I looked up the specs and I just ordered it. It was the same as PC RAM. Some Macs do require specialized error checking RAM and stuff like that. So if you're really worried about it, order this. And then here's server memory. So again, you know, this one is ECC RAM. You know, here's super micro, blah, 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 DDR4 3200. Notice it's got the PC rating, PC4 25,600. So that's 3200 times 8. And this does happen to be error checking and correcting RAM. Notice the price is also much higher, right? So definitely paying for the different stuff. It's registered RAM as well. So, all right. Okay, so you guys had a small assignment for this class of, you know, looking up your computer specs. We looked at Speccy as a tool. You've got the PC system information tool that's built into Windows. I was trying to think if there was, I know there was another one we've used. Yeah, CPU-Z, oh, hardware info. There's a ton of them out there, so I'll share this as well. CPU-Z is also good, typically just for CPUs, but it also shows stuff about your motherboard and other stuff. A lot of times when I'm looking for a particular piece of software and I can remember one, another handy Google search is there's alternative to Speccy, and it'll list out a bunch of stuff. Like, so for instance, this is alternative2.net right there. So Speccy so if you can remember one piece of software, but you're trying to think, okay, I've got this one, or I've used this one and it was okay, but what are some of my other choices? So here's a ton of them here. CPU-Z, hardware info, hard info, GPU-Z for graphics cards, NeoFetch, that's command line. That might be kind of weird, but oh, that's Mac. Oh no, it's got Mac, Windows, Linux, blah, blah, blah. CPU-X. All right. a bunch of them out there. So Speccy would be good. You guys also might also like CPU-Z. It's put out by the sir. It says it's malware. No, I don't think it has. I don't want to send you in any websites that have malware, but I don't think it does. So yeah, it's CPU ID as the parent company. So that would be a good one to check out. I'll put that as a link into the chat or on the discussion board as well. So just basic stuff. And then also you guys are going to have your quiz is the next one up for grabs in our all right, I was checking out the chat. All right, so anyway, your quiz is the next one that's going to pop up, so be looking forward to that. I know that's always fun. And then one of our assignments, kind of longer term, which also it's kind of fun, is to just think about if we were going to be building a computer, how much we want to spend, and if we have something specific. So like somebody was asking a while back about VR headsets, like a specific VR headset. What kind of hardware do you need to support that wirelessly versus wired and stuff like that. And we went through that in class. We bought that HTC Vive headset, and then we had to build a computer that would support it because you need super fast frame rates. The big thing was our graphics card wasn't up to the task. So we had to buy a new graphics card to make that work for the classroom. So, all right. Yeah, we're about done for today. We'll talk more about system memory on Monday. You got a quick assignment of like basically specking out, specking out your system so that we kind of get an idea of like what do you guys have on your own computers. Oh, that was what I was going to show you too here is.
Do you want us to, you said to write it out, so text it out, or you want us to just include like screen pics of?
I lost my screen here. I gave you the option of both, I believe. So yeah, it was just text information. But if you wanted to submit screenshots or pictures, I put it as you could do a file upload as well. So I'll double check that I allowed file uploads. So that would allow you to upload actually a picture of your computer. If you've got a computer that's got lights and smoke machines and cool stuff like that, who knows? Do that if you want. I mean, I kind of left it open. So you can do screen grabs of the spec information as well. So yeah, if you go to crucial.com, it's got a scanning feature. So this is another one, because remember I was asking about like, on my computer or any computer, you might be wondering if you have empty slots for RAM. And some of the scanning programs will show that, like, the Speccy or in some of those, they might show, your motherboard and you've got two pieces of RAM or two memory modules populating and you've got two empty slots. But if you go to crucial.com, and then you just choose the option to scan your computer. There we go. Get us out. So if you say scan your computer, it downloads this tiny little file. No thanks. Oh, agree. Start your scan. I've downloaded before. So anyway, it downloads a tiny little program. You can run it on your system. This is really handy if you're helping other people. We're almost out of time, but if you're helping other people and you don't want to open the computer up. Now, laptops, a lot of times you can look up the specs anyway, and a lot of laptops only come with two slots to begin with, but there we go. I thought I ran this already. It's opening it up on another window somewhere. All right, I've got way too many windows open, but it's supposed to show you specs on your computer, whether you've got empty memory slots or not that you can upgrade to, and memory pathways. And the idea is that, they would, and then they'll say, oh, and here you go. By the way, we've got this RAM that you can also buy. You don't obviously have to buy your RAM from crucial.com or hard drive upgrades or whatever, but you can scan your computer quickly It opens up a little website and you can see what, see what's on there, and it just kind of does an internal scan. It's pretty effective tool, and it doesn't require you opening up the case. So if you're helping somebody and they have internet access, you can go to crucial.com, try it, scan your computer, see what your results are. And you don't have to crawl under their desk and open it up with a flashlight and see, okay, yeah, you've got space that you can put RAM. Because as I mentioned, a RAM upgrade can be a pretty effective upgrade pathway. For most people though, I mean, going to like 32 gigs of RAM, they're not going to use that RAM. I mean, that's not going to be something that they're going to make use of. 16 is kind of a sweet spot. It kind of depends on what the person's doing with the computer. If they currently have 4, bumping it up to 8 gigabytes would be a good quick upgrade for a lot of computers, help them run Windows 10 better and stuff like that. So if you get into the position of people asking you for help or asking you about what you want to do with your computer, that's a good one that you can suggest, and easy to do, especially if they have empty slots. You don't end up with leftover components that you have to toss out or throw away. So, all right, we're out of time. Take a look at Canvas. Keep up with these two. We're kind of going back and forth between the 2 classes. We're 3 actually, and so you guys will have a quick quiz for the hardware stuff. Hopefully, it's not too hard. So we'll take a look at that. Ryan, question, go for it.
Yeah, really quick question. So which one's more difficult of like upgrading, a laptop or like an all-in-one desktop computer?
It totally depends on the computer. Some of those all-in-one computers are kind of hard to take apart. You're talking about one with the screen and the computer are the same thing, right? Like built into it. Yeah, some of those are easy. They have a panel on the back where you just open up the panel and there's your hard drive, and another panel and there's your RAM. Laptops the same way. Some laptops are really easy to get into, and others are a little more convoluted. We have to take the keyboard out and your RAM might be underneath the keyboard. So there isn't really a good answer for that. It just totally depends on the computer. They're all over the board. Google it and look it up on a YouTube video, and guaranteed there's somebody taking that computer apart, and you can see what it looks like when they take it apart. So look up the model number and all that. Cool. All right, you guys, have a great weekend. We'll meet back on Monday. Keep an eye on Canvas so you don't miss stuff.